The following function models the maximum weight W that a person can bench press in pounds at the end of T weeks of working out. So this is the function W of T equals 250 minus 150 e to the negative 0.5 t. What is the maximum weight that this person can bench press initially? So initially is at the beginning of the time period, and so that means our time is equal to 0. So we'll substitute a 0 into the function to get 250 minus 150 times e to the negative 0.05 times 0. That's 250 minus 150 e to the 0, negative 0.05. Oops, I've got a mistake there. That's 0.5, not 0.05. Negative 0.5 times 0 would be 0. And e to the 0 is 1, so this is 250 minus 150 times 1, and that's 250 minus 150, which is 100. So at the beginning, this person can bench press a maximum weight of 100 pounds. The next part says, what is the maximum weight that this person can bench after 2 weeks of weightlifting? So after 2 weeks of training, 2 weeks at t equals 2. We'll substitute a 2 into our function. I'm going to write that down here. W of 2 is 250 minus 150 e to the negative 0.5 times 2, and this time, because we're substituting something other than 0, I'm going to type it into the calculator to get the value. That's 250 minus 150 e to the negative 0.5 times 2. So at the end of 2 weeks of training, this person can now bench press a maximum of 194 pounds. We're going to round to the nearest whole number and say 195. In the next part, what is the maximum weight this person can bench press after 8 weeks? So after 8 weeks, that means t equals 2. Sorry, that's t equals 8. And we'll substitute that into our function. 250 minus 150 e to the negative 0.5 times 8. And we'll type this in our calculator. So 250 minus 150 e to the negative 0.5 times 8. And at the end of 8 weeks of training, this person can now bench press 247 pounds. The relative growth rate of a certain bacteria colony is 25%. Suppose there are 11 bacteria initially? Use the exponential growth model, P of t equals P naught e to the kt, to answer the following. Find the function that describes the population of bacteria after t hours, and how many bacteria should be expected after 1 day. So we're given this model for exponential growth, P of t equals P naught e to the kt. We need to understand the pieces of this model. The P naught is our initial population. So the population at the beginning. The K is our growth or decay rate. In this case, growth. And then T is our time. I want to read the question one more time to see if it mentions a time period. So we'll notice here that it says find a function that describes the population of bacteria after t hours. So the relative growth rate of a certain bacteria colony is 25%. Assume there are 11 bacteria initially. And so this gives us an initial population of 11 bacteria, and it gives us our growth rate of 25%. And we'll write that growth rate in decimal form, 0.25. So we can write our function that describes the population as 11 e to the 0.25 t. So this answers the first part. Then in the second part, it says how many bacteria should be expected after 1 day. And we'll notice that the first part of the question is talking about hours, and the second part is talking about days. So we need to be consistent. So since the first part we did in hours, we need to convert the days to hours. So there are, in 1 day, 24 hours. And I'll substitute a time of 24 hours into this model. For time, and then I'll put it in our calculator to figure out what the new population will be. We have 11 e to the 0.25 times 24 hours. So we have a new population of bacteria, which is 4,437. We'll round to the nearest whole number, so that's 4,437. So the bacteria that we expect after 1 day is 4,437. In this question, we want to use the periodic compound interest formula. The question says, how much money will you have in 4 years if you invest $9,000 at 6.3% annual interest rate, compounded quarterly? How much will you have if it's compounded monthly? So there are some key words in this problem that tell you which compound interest formula to use. And here where it says compounded quarterly, and here where it says compounded monthly, indicates that you would use the formula A equals P times 1 plus R over N to the nt. The other formula, which is a equals p e to the rt, is for situations when interest is compounded continuously. So let's identify these different values within the problem. It says, how much money will you have after 4 years? So we have our time of 4 years. If you invest $9,000, that's our principal, our initial amount of money, at an interest rate of 6.3%, that's our rate, 6.3%, and we're going to write that in decimal form, 0.063. And if our interest is compounded quarterly, that is going to give us the value of n. So since it's compounded quarterly, that's 4 times a year, and n will equal 4. We're going to substitute these values into the formula to get a equals 9,000 times 1 plus 0.063 over 4 to the 4 times 4, and we'll type this in our calculator to get the value. We have 9,000 times 1 plus 0.063 over 4 raised to the 4 times 4. So that $9,000 would grow to be $11,000, $11,556.65. That was 65 cents. And then in the second part of the problem, interest is compounded monthly instead. So the first one was quarterly with n being 4, and then we're compounded monthly, which is 12 times a year, so n is 12. So we'll calculate again using n equals 12. It's 9,000 times 1 plus 0.063 over 12 to the 12 times 4. We'll type this in the calculator. $9,000 times 1 plus 0.063 over 12 to the 12 times 4. And with interest compounded monthly, we would have $11,571.73. So if you compare these two values, you can see that you get a little bit more money by compounding monthly versus compounding quarterly. When your interest is compounded more often, your account can grow a little bit faster. Thank you for checking out my videos. Have a great day.